So I will somewhat be continuing on what Rebecca spoke about. We have the same sort of basis for the work with you also through the joint Polar Semantics working group. So I think we are end now, so stop there. This is not a presentation of the working group as such, but it's based in some observations from working in the working group and aggregating data across data centers for a long time since the International Polar Year. So it's based also on some of the documents that we are working on in the Polar Semantics working group. I would like to go a bit back, and I'm not a semantic expert like Rebecca. I don't know definitions of things. I use whatever I find on the internet, just everything, but there are many different definitions of science as well. I don't read all the words, but for me, the important step is the systematic study. So how do we do work with our data in a science context systematically? And we use the data to test theories against the evidence. So data is the evidence of what we observe somehow. I'm not going into the discussions of what is data or anything like that. And a requirement in order to do this is actually to share the terminology. And I find this kind of interesting because when I went to university, I learned about theory, observational methodology. I learned about ethics and a number of things. But the whole concept around data and how you structure data, we never learned anything about. I think it's improving, but it's still a challenge in much of the science education or education of scientists. So for me, this shared terminology is the important step. We need to identify it and we need to actually use it in practice. The problem is also that in science, we have different directions. We have different disciplines. So a biologist do not necessarily speak the same language as a methodologist or a oceanographer. I've been working now in a huge project together with Luke here for a long time, and Øystein with the Nansen legacy in Norway. We have a lot of people working in instrument science-oriented data, but it's basically then oceanography, biology, meteorology, glaciology that people are working with. No social sciences in there, at least some on politics, but the prime, also the majority of the activity is on the classical disciplines. The point is that I learned there as well was that biologists, at least marine biologists, do as many observations of the physical conditions in the ocean as the oceanographers, more or less. But they do use a different language to describe them. And how do we actually match between these ways of describing the data and bridge? Because the same observations that biologists make are important and useful for the oceanographers and vice versa. So we need to sort of bridge between the disciplines. We need to bridge also towards social science and other qualitative approaches. There's a lot of things we need to work on there, but at least that's the problem we have to address. And in the polar regions, things are changing quite rapidly. And we have small communities, and there is a good opportunity to actually start the work of bridging between the communities and also towards politics and the decisions made on top of the science results. The problem we have is that the disciplines make it different as a description, create different descriptions in how data are documented. And this also affects the interpretation we can make of the data. And everybody talks about the fair guiding principles. And it's kind of interesting because it's, first of all, it's just an observation from my side. When people say fair, quite often they mean far. I forget about the I and the R. And you really need to go into the I and the R, and I've highlighted some of the elements where the semantic approach comes into play. It's not just about dumping data in a storage somewhere. You have to give some context around the data. And that's where you have the semantic elements that that comes in. If we don't do it, we have reduced interoperability, and we have issues when we try to integrate information. And Rebecca also mentioned some of these place names. It's actually use information if you have an observation. You can have a geographical position, also using the coordinate system, but the place name can equally be important in this context. I grew up with parents, grandparents, etc., that were fishermen and farmers. They never used a GPS position or anything like that. It's all about positions according to the landscape and what we see around us. And there is a lot of contextual variables that we need to work on. But also the measured variables that we have. Whenever we measure a temperature, where is it? Is it in the ocean? Is it in the soil? Is it in the atmosphere? At which level in the atmosphere? It means different things when you interpret it. And this is a problem we have today because people just say temperature and dump it somewhere. They have no context around the data. So semantics can help to generate this framework around the information that we really need to do. And my statement would be that the semantic approach is key to the scientific method. Because if we don't use this, we lose the shared terminology, and we actually, I don't know the English word of it, but my grandparents, they had a word of synsing in Norwegian. It's just, you state something, but you have no evidence of what you're stating. So we need this sort of context around the data. And I'm also looking at this old paper from Rasakat that Rebecca had a reference to. It's from 1989, From Data to Wisdom. I know also in the working group, some people don't like this, but I like this illustration quite well. And I've taken away the top part here, which says wisdom, because I find it hard to relate to the concept of wisdom. But I can relate to data. So whatever some instrument puts out, that's data to me. It's a value. But I don't have a clue on what. So when I move, I put some semantic context around the data, I got information. Then I can say that it's a temperature in the air measured at a specific location in time, for example. And I can also get the information about the procedures used to actually measure that temperature, who did it, and which instrument did I use, how often were the instruments calibrated, etc. And once we've moved from data up to information, then we can extract knowledge from it, and we can communicate that to other parts of society. So this is, for me, what semantics does for us. It moves our data into the information domain, and we can extract knowledge from it. So semantic data is data that has given a context and meaning, because otherwise data is just data. Whatever your temperature sensor measures, again, starting with instrumental data, if you have a weather station with a temperature sensor, it's a count value, it's a number that comes out. It's not a temperature as such. There is a procedure behind converting that to an observation of the surroundings. So semantics helps us do the data integration. And what we are really looking for here is not a number of individual weather stations that are disconnected. For example, in WMO context, we need to look at all those weather stations in a whole. So integrating across all the weather stations that we have available. And also equally important, if we use the semantic approach and the technology that has been developed around it, we can use the computers to actually help us interpret the data. Today, too much of the information is communicated between humans, and then you need to integrate the human in the value chain at all times. But instead, we should put the human at the end of the value chain, not by actually just preparing data for interpretation, but spend the time on interpreting the data. But then we need to set up the system so that the computers can actually help us in that context. And semantics in the polar context is no different to semantics elsewhere in the world. So we should never develop anything specifically for the polar regions. You should always try to focus on reusing and contributing to what is already available for describing our scientific data. And then I would just go into some of the elements on the working group. I normally call it the Polar Semantics Group. Rebecca called it the ADC Ceylon Semantics Group. I think the official name long time ago was a joint effort by the IARPIC and the ADC, but it's an open group, basically. We talk about semantics in the polar context. It's open to any interested parties. We have virtual meetings. We try to have them regular for a while, and now it's been somewhat irregular, and then we try to catch up again. There is a website that you can find more information on. There is a QR code at the top. You will see that at the end. It's easier to use there. And what we try to do in that group, it's a group that is composed by semantic experts, but there are also people like me. I'm not a semantic expert. I'm not a linguistic or anything like that. My education is in meteorology and oceanography, and I've done data management for a long time. But I see the value of the semantic approach in order to describe the data. From my perspective, is on the data provider and data center side. I'm not into the sort of science of semantics. I see the practical aspects of it. But there are also people that know the science of semantics, and we try to discuss between us and how to set up, understand semantics in our context. And there is then an activity to promote the awareness of existing vocabularies and semantic initiatives that can help us, whether we produce data or we manage data on behalf of other people. We are coordinating activities, development activities across the polar information community. We try to organize regular communication within the community, and we try to help the community to connect to the useful information. There's a number of documents under development, and we had a session during the last Polar Data Forum, but it's sort of, there's now a focus on developing some of the documents and releasing them to a wider community. And we also try to connect with whatever is happening within the Research Data Alliance, ESIP, etc., because those communities are much more dedicated to this activity. I won't go into the details here. There's a list of activities we're working on and the status. One thing that is probably a bit important or interesting here from the last presentation is 7A definitions of data and data sets that could be used in the public community, a direct link to Rebecca's presentation. We've set up a GitHub area. There's a link for that. And we've got some information about semantic resource types. And this is where I really would like the awareness of data providers and data centers. We really need data centers, at least, to enforce usage of either controlled vocabularies, glossaries, thesaurus, taxonomy, or ontologies in order to describe the data. It's about the variables. It's whenever you put URL in the discovery metadata, because me as a consumer, I don't have a clue on that URL. If you say get data through this URL, I need to know the protocol, for example. Then I can set up a decision system or a value chain using those data in a practical form. We do have a meeting this afternoon as well. Everybody's welcome to join that. And then we can so that we have a meeting room at least, and then we can decide on the agenda when we're in the meeting room. And this is the QR code for the website. But my main message is that semantics really matters. It is what creates the context of your data. If you don't have the semantics, you are not able to create useful value chains around the data. And this I will also present later today when I present the ambitions of Arctic Passion. I have a project that I'm involved in. Thank you. Fantastic.
Anybody have a quick question for Øystein? Yes.
Can you go back to that slide that has the graph and you took off the word wisdom? I find that fascinating because I think that wisdom is at the beginning. And I think, and I'm prefacing this way because I think it's also not a line. I think it's a circle, a continuous spiral. Because how do you know what data to collect if you don't have the wisdom, which I would consider the context, the cultural context and specificity to know what data you're trying to. I hear it's a ball of yarn. It's a ball of yarn, says Rebecca. And I just wonder if it's easier for the simple science that you're in to remove it because it's easier. And I think that's fine. I'm wondering if you could think about that.
So the reason why I took it away now is that it plays a role at some point. But for me, as long as you don't do the proper things down here, it doesn't help there. And of course, it connects around again. Everything is a circle if you look at the science workflow and these things. So I haven't put much effort into this. It's actually an illustration from an old paper from 1989, I think, that has been redrawn many times. I totally agree on the circle approach that you have. It's just to me that this wisdom concept it can go off in different directions. And what I really wanted to focus here is to move from data into information where you can actually extract and use to something. But I'm happy to continue the discussion about this. And no prestige in my area on wisdom or not wisdom. In previous presentations, some people have complained about the wisdom concept, and some people don't like it.
Clever, thank you.
Was that answer?
It's perfect.
Thank you very much.